In this section, we're mostly actually just going to be reviewing the topic from the last lesson, which was on graph quadratics by factoring. To start, I'd like you to try this warm-up question that I found in an ACT/SAT prep book, because it actually connects to something that we've been talking about. So it'd be good ACT/SAT prep review. So the question says, which of the following is the sum of both of the solutions for the equation x squared plus 3x equals 54? I'd like you to try this either at the bottom of your last homework or in the margins of the note packet, just somewhere you can find a little piece to work on. You don't need a ton of space to solve the question. Let's just pause the video now, come back after a minute and everyone's had a chance to try so I can go over what the correct response would be. Okay, here we go. So it's asking for the sum of both of the solutions. So the first thing you need to do is to solve the equation. This is a quadratic, and we've been solving quadratics by factoring recently. In order for that to be useful, you need one side equal to 0, so your first step should be to subtract 54 from each side. You'll then get x squared plus 3x minus 54 equals 0. Now I need a factor. I need two numbers that multiply to make negative 54 add up to be 3, and those factors are going to be 9 and 6. So x plus 9, because I need them to add up to be a positive 3, and x minus 6 are going to be my factors, which means the solutions are negative 9 and positive 6. If you then take those answers and add them together, because it asks for the sum, negative 9 plus 6, it should be negative 3, which means the correct answer is G. So there you go. That's how you'd solve that one. You then need your note packet out to, it should say something about like the second day for graphing x squared plus bx plus c by factoring. To make sure everyone has that to start, go ahead and do so. Otherwise, I'm going to assume that we're good to go. To start, I'm going to actually already give you one that's factored. So it says I've already factored the following quadratic function. Use it to pick out the key pieces of information. I already found two numbers that multiply to make negative 12 add up to make negative 4. So that first step is done for us. Now we need to find the zeros. The zeros are the x values that make y be 0. So I would then say they're going to be what? 6 and negative 2. And I would start by plotting those on my graph. I've already sketched the graph in there just to show where all these things we're going to find appear on the graph. Once you find your zeros or your x-intercepts, you know the vertex is halfway in between. Halfway in between is just the average. So the vertex is x-coordinate, which we also note is on the axis of symmetry, is going to be the average of the two x-intercepts. 6 plus negative 2 divided by 2 is 4 divided by 2, and that's 2. That's why we see this axis of symmetry occurs along the vertical line x equals 2. If I know the x-coordinate for the vertex, how do I find the y-coordinate? So I know the vertex has an x-coordinate of 2. Its y-coordinate will occur when I put 2 in for x in the equation. So the vertex's y-coordinate is going to be when I put 2 in for x in the equation. 2 squared minus 4 times 2 minus 12. You actually could have put 2 into the factored form one also. That might have actually been easier. We did this using the calculator if you'd like. You would type in the equation 2 store for x and hit enter. Then you type the equation in, x squared, so x squared, subtract 4x, subtract 12. It tells us the vertex's x-coordinate should be all the way down at negative 16. Or sorry, the vertex's y-coordinate should be down at negative 16. So it's going to be right there. The last point is the y-intercept. The y-intercept is your y value when x is 0. If you put 0 into your equation, this part will go away, this part will go away. It will have to be the c value at the end if you go ax squared plus bx plus c standard form. So the y-intercept is 12. If you know that that's the y-intercept, you know that there's going to be a point reflecting on the other side right there, and there's the 5 points you'll get. You'll get the 2 red x-intercepts, the blue vertex, the green y-intercept, and its reflection that I've shown in black, and then you would sketch in the graph as shown. If you want to use a calculator to check, you always could, but I'm going to ask you to show your work for all these steps to find the characteristics. So you have to be able to know where they come from, but you can always check your work in the graphing calculator by going to the y equals button, hitting clear if you need to, type in your equation, x squared, subtract 4x, subtract 12. you might need to adjust the window. So you can either hit window and then adjust your window manually, or you can do zoom. And I think there used to be a zoom fit. Yep, you scroll down, it's option 0, so past the 9 because they don't do a 10. Zoom fit might be good. That's not great. We should actually probably go back to zoom. I'm going to do 6 standard. The only downside is you can see it doesn't go down far enough. So if I go to window, I can make that Y minimum go down. We know that the vertex is at -16, so let's make it go down to -20. Then if I ask it to graph it now, 8, it gives it a graph. The downside is it's kind of pixelated, so it's not going to be great. If you hit this little trace button, though, it will allow you to move along points on the graph. So there you go. So you can check using the graphing calculator, make sure that you're in the right ballpark. I'm going to ask you to try one just like that, where I've already factored it for you. This one you don't need to graph it. I just want to know what the key characteristics would be. So on your own, pull out your whiteboard, and your task is to find the zeros, find where the vertex will be located, and find the y-intercept. So pause the video now, give people maybe a minute and a half to try this question. You don't need to graph it. Just pick out the x-intercepts, the vertex, and the y-intercept. So pause the video now, please. Okay, here we go. First part, you need to find where the zeros are, and that's going to be the x values that make y be 0. So they're going to be at -2 and -3. The vertex has to be halfway between. Halfway between -2 and -3 is -2.5. If you take -2.5 and you plug it in for x, you could either do it into the standard form or into the factored form one. I'm going to do it in the factored form one because I can do this in my head. If I put -2.5 in for x here, I get -0.5. If I put -2.5 in for x here, I get +0.5. -0.5 times +0.5 is -1/4. So there's going to be my y coordinate of my vertex, and then the y-intercept is the y value when x is 0, which is going to be that value at the end. So there you go. Your two x-intercepts are at -2, 0, and the other one's at -3, 0. Your vertex is shown in blue. Your y-intercept is shown in the green. That's what you should be able to do. We're going to try 2 more, and then that'll be it. So we're going to try where you have to do it all the way from the beginning. So first thing you got to do is factor it. I'd already done that for you in the beginning one. So set y equal to 0 and factor it. Two numbers that multiply to be 12 add up to be 8 are going to be 2 and 6. So x plus 2, x plus 6, which means your zeros are going to be at -2 and -6. And you plot those, -2, -6. The vertex has to be halfway between. You can do the whole averaging thing, but this one you really don't need to. You can just look and know that halfway between -2 and -6 is -4. And that's where the axis of symmetry is going to be. So that's going to be the middle of my parabola. So the vertex will have an x-coordinate of -4. If I put -4 into my original equation or into the factored one, I'll do the factored one because it's fairly easy to do in your head. If you put -4 in here for x, -4 plus 2 is -2. -4 plus 6 is +2. -2 times +2 is -4. So the vertex's y-coordinate turns out to be -4 as well. I'll show what I did. Just plugging -4 in for x, because then it will output the y-coordinate for me. -4 is right there. The y-intercept is this value at the end, 0, 12. Plot that, and then sketch it in. There'll be a reflection right over here on that side, and you'll be done. If you want to use a graphing calculator to check it, feel free. You might need to adjust the window again. Maybe go from -10 to +10 on the x-axis, -10 all the way up to maybe at least 12, maybe go as high as like 16 or something on the y-axis. So there's kind of a fairly standard one. We're going to do one special case one, and then that'll be it. So here we go, last one for the lesson. I think there's a few that are actually in the homework like this. So if they start with a negative out front, you're going to need to divide the negative out. This one's kind of doubly special because not only does it have a negative out front you need to divide out, it only has 2 terms, which means the type of factoring that you're going to have to do is GCF, greatest common factor factoring. So when I factor this, because I want to know the values for x that are going to make y be 0, I'm going to write this all out. Negative 1x squared minus 3x. So I start by dividing out the most common number. The most common number between negative 1 and negative 3 is obviously a negative 1. Between x squared and x, the most I could divide out is a single x. In parentheses, I write what's left behind. There was a negative 1, I divided it out. This had two x's, I divided one of them out, so there's a single x left. This was a negative 3, I divided a negative 1 out, so it has to be a positive 3 left. This only had one x, and I divided it out. So that's what it looks like if it's factored. Now I find the zeros, or the x-intercepts. They're going to be at negative 3. What would I multiply negative 1 by to make 0? Well, it's not positive 1, because negative 1 times positive 1 is negative 1. It actually has to be 0. So 0 and negative 3 are going to be where the x-intercepts are. The vertex's x-coordinate is halfway between. I hope by now you can do this in your head and just know it's going to be negative 1.5. How do I find the vertex's y-coordinate? I'm going to put negative 1.5 in for x in the original equation. That I'll actually do it by storing in the calculator just to show. Negative 1.5, store that for x. And now I type in the calculator the equation. Negative x squared subtract 3x, and when I put negative 1.5 in for x, the y-coordinate is positive 2.25. So I'll show what we did. And we got positive 2.25. So the vertex is going to be at negative 1.5, 2.25. Right? Negative 1.5. 2.25, so like right about there. Last part is the y-intercept. There's a plus 0 at the end, which means the y-intercept actually is redundant with the x-intercept. So in this one, we only get 3 points. Sketch it from there. It'll look something like that. So if you have a greatest common factor factoring problem, you're only going to get 3 points. And that's it. You should be able to graph by factoring using examples that we did in the prior lesson and in this lesson. So that's it for today. Thank you very much and have a good day.